Hello everybody, my name is Chris Aguilar, and this video is being made for my Fundamentals of Physics class for my instructor Raul Vargas. Today I will be talking to you about the physics of magnetism and the effect it has in the video game industry. When it comes to physics in video games, you can pretty much talk about anything. What makes physics so special in a game though is the fact that it doesn't have to follow any laws. In fact, breaking the laws of physics makes for a great game that the players can entrance themselves in. Who wouldn't want to be able to naturally shoot flames or lightning bolts out of their fingertips? Or, perhaps relates to my topic, the ability to control metals like Magneto. Anything you can imagine can be put into a video game, but even if it breaks the laws of physics, you still need to be able to understand it. Magnets are named after an ancient city called Magnesia, where unique stones called lodestones were found, which they noticed had the ability to attract pieces of iron. I find magnets to be one of the most interesting objects on the planet. Speaking of planets, the Earth itself is one massive-sized magnet. If it weren't for Earth's magnetic field, the cosmic radiation that the sun throws at us on a daily basis would obliterate us. Every magnet possesses a north and south pole. To put it simply, like poles repel and opposite poles attract. Something I found very interesting is how Earth's North Pole actually lies south in Antarctica, while its South Pole lies north in the middle of the Arctic Ocean. Now, what I have here are two magnets. From this angle of them, this side's going to be north and this side's going to be south. Same with the other one. Now, when the two north come together, they're going to repel. See, I'm trying to push them together, but they don't want to go. They want to repel. But if I move them one of them just slightly, one north is going to attract the south. So now they're stuck together. Again, they repel if I match them up. So opposites attract. Now I'm going to be demonstrating to you how a magnet reacts to certain metals like iron and explain how magnetic domains work. First things first, if I've learned anything from Bill Nye the Science Guy, safety first. Now in this ordinary nail are many tiny iron atoms that each have their own magnetism aspects that create clusters of atoms to travel together. These clusters are called magnetic domains. Without the magnetic field that emits from a magnet though, these clusters are scattered about without organization. When a magnet approaches these clusters fall into place and create a north and south pole in the nail, inducing the nail to be magnetic. So we have a magnet here. Magnet. I have the nail sitting right here. Now, once I approach it, the nail gets attracted to it. So now this nail is magnetic. So if I bring another nail into the picture, that nail is attracted to the nail because it's magnetic now. And this can pick up large quantities of nails. Now, these magnets can induce anything, like this hammer. Lots of iron in this hammer. See, attracted to it. Not enough power. Gravity pulls more on the hammer than the power of this magnet. If I bring two into the picture though, that doubles the magnetism. And you can now hold the hammer. These magnets can travel awfully far with power. So this hammer is magnetic. Now the hammer can pick up the nails. Voila. That's how magnetic domains work. Now something that's really interesting is if I were to put both north and a south pole onto this hammer, it loses its magnetism. So now two magnets are on it, but it won't pick up the nails now because it now has both north and south randomly occurring. Again, now make it one north pole and it attracts them. This is a flash game I discovered that demonstrates the push and pull of magnets. It's called Magnetic Rush and you can play it for free online. As you can see, you can control whether the magnets are attracted or repelled from each other by using the up and down arrow keys.